Synthetic fertilizer overload. Synthetic fertilizer overload happens when farmers dump too much manufactured nitrogen onto their fields. Back in the early 1900s, scientists figured out how to pull nitrogen from the air to make cheap plant food. Today, we pump over 100 million tons of this stuff into the ground globally every single year. The goal is to feed crops, but plants actually only absorb about half of what gets applied. The rest stays behind. These synthetic fertilizers are essentially heavy salts. When you add too much, the salt concentration in the dirt spikes. This salt acts like a dry sponge. It pulls water right out of the cells of beneficial soil bacteria and earthworms. The microscopic bugs and worms simply dry up and die. You are left with lifeless dirt that quickly turns hard and dusty. Without these tiny helpers to naturally break down organic matter and aerate the ground, the soil loses its ability to grow healthy food in the future. Broad-spectrum herbicides. These are weed killers designed to destroy almost any plant they touch. The most famous one is glyphosate, which hit the market in 1974 and quickly became a standard tool for farming. You spray it on a field, and the chemical absorbs into the leaves, traveling down to shut down the roots. But the chemical does not just stop at the weed, it leaks into the dirt and damages the beneficial mycorrhizal fungi. These tiny underground fungal networks act like an extra set of roots. They connect to crops and reach deep into the soil to pull in water and nutrients. When herbicides wipe out these fungi, the surviving plants lose their lifeline. The visible result is a crop that looks stunted, pale, and wilts much faster during a drought. This still matters today because healthy dirt is the foundation of our food supply, and breaking these hidden networks forces us to rely on artificial fertilizers just to keep things growing. Fungicide soil drenching. This is the practice of pouring liquid chemical fungicides directly onto the ground around the base of a plant. Since synthetic fungicides became popular in the 1950s, growers have used this method to saturate the root zone. They mix the chemicals with water and pour it right into the dirt. The goal is to kill the harmful fungi that cause diseases like root rot. The liquid seeps down and wipes out the infection, but it does not stop there. It acts like a bomb in the dirt, indiscriminately eradicating the good fungi too. It completely destroys the delicate mycorrhizal fungi networks that physically attach to plant roots. Without these tiny fungal threads holding things together, the soil loses its loose, crumbly structure and packs down hard. This matters today because nearly 90% of land plants rely on those beneficial fungi to absorb water and nutrients. When we sterilize the ground to save one plant, we accidentally cripple the soil ecosystem it needs to survive long-term. Routine pesticide spraying. Routine pesticide spraying is the habit of treating a garden with chemicals on a set schedule just in case bugs show up. After World War II, synthetic bug killers became wildly popular for everyday home use. The idea was to keep plants pristine by coating them in a chemical shield before any damage even happened. You load up a sprayer and drench the leaves, stems, and soil every few weeks. When those chemicals hit the garden, they do not just kill aphids or caterpillars. They wipe out almost everything. The spray destroys the beneficial ladybugs, spiders, and microscopic soil bacteria that actually eat pests and process nutrients. Without these natural predators patrolling the leaves and roots, the garden completely loses its own built-in defense system. This still matters today because the targeted pests usually bounce back much faster than the helpful insects do. You just end up trapped in a cycle of spraying more chemicals to keep the plants alive. Ignoring chemical half-lives. This happens when people spray weed killers without checking how long the chemicals actually stay in the dirt. Every chemical has a half-life, which is the time it takes for half of the active ingredients to break down. Back in the 1960s, companies started selling highly persistent herbicides like picloram to clear out tough brush and pasture weeds. You mix the spray, coat the target area, and watch the weeds shrivel up over a few days. But the chemical does not just vanish after the weeds are gone. It binds tightly to the soil and decaying plant matter. If you try to plant a sensitive crop like tomatoes or peas in that same spot even a year later, the damage is obvious. Your new plants might sprout, but then their leaves twist, turn yellow, and die. Chemicals like picloram can stay active in the ground for up to 3 years, effectively sterilizing the bed. This matters because a quick fix for summer weeds can quietly ruin your soil for multiple growing seasons. Improper dilution ratios. This happens when you mix garden chemicals at a higher concentration than the label recommends. Ever since synthetic pesticides and fertilizers flooded the consumer market in the 1950s, backyard gardeners have mistakenly thought that if a little is good, more must be better. You pour a heavy glug of concentrate into your sprayer instead of measuring it out. When you spray this supercharged mix onto your garden, it drops a massive load of salts and active compounds straight into the topsoil. The immediate result is acute toxicity. The high chemical concentration pulls water right out of the plant tissue. You will quickly see chemical burns on the roots, turning them brown and shriveled, while the leaves above ground scorch and drop. Down in the dirt, the harsh chemicals trigger a total die-off of the beneficial microbes. This still matters because long after the initial mistake, your garden's topsoil remains a barren wasteland that takes seasons to naturally rebuild. Applying before rainstorms. This is the practice of spraying pesticides or fertilizers on fields or lawns right before a heavy downpour. People sometimes rush to get treatments down, hoping the rain will just gently water everything in. But when a massive storm rolls through, that sheer volume of water acts like a heavy plunge. It grabs those highly concentrated chemicals and shoves them straight down, deep into the soil. Down there, the sudden flood of toxic liquid poisons deep-dwelling organisms like earthworms and beneficial microbes. Worse, the chemicals keep sinking until they hit the water table. Historically, before laws like the 1972 Clean Water Act stepped in, unchecked runoff heavily polluted public wells across the country. Even now, the Environmental Protection Agency notes that agricultural runoff is a leading cause of groundwater contamination. This still matters because once those toxic chemicals enter our underground aquifers, they are nearly impossible to clean up. They just sit there in the dark, quietly compromising the drinking water that millions rely on every single day. Blind pH adjustments. This is when you dump chemicals like elemental sulfur or aluminum sulfate into your garden without actually testing your soil first. Historically, farmers have used these compounds for decades to fix overly alkaline dirt and bring the pH down to a healthy 6.0 to 7.0 range. But doing it blindly is a gamble. Aluminum sulfate dissolves almost immediately, while sulfur relies on soil bacteria to convert it over several months. When you just guess the amount, you dump a heavy chemical load directly into the dirt, causing the pH to plummet way past your goal. This creates a sudden, toxic extreme underground. Essential nutrients like phosphorus lock up and become completely unavailable. Meanwhile, toxic levels of aluminum are released, stunting the roots. Above ground, your plants turn yellow and look starved. This still matters today because fixing a crashed soil ecosystem takes months of expensive repair, proving that a cheap soil test is always better than guessing. Starving organic matter. This is what happens when you feed your plants nothing but liquid chemical fertilizers. Ever since the Green Revolution in the mid-20th century, farming and gardening shifted heavily towards synthetic feeds. These liquids deliver a quick hit of nitrogen, phosphorus, and potassium right to the plant roots. But they completely bypass the soil microbiome. Microbes, beneficial fungi, and earthworms do not eat synthetic chemicals. They need carbon from organic matter like compost, decaying leaves, and mulch. When you only use liquid feeds and stop adding that organic matter, the microbial food web starves to death. The visible effect is obvious. Without microbes to glue the soil particles together, the ground loses its spongy texture. It turns hard, compacted, and dusty. Water runs right off the surface instead of soaking in, turning living soil into dead dirt. This still matters today because rebuilding dead dirt takes years of effort, and we rely on living soil to grow resilient crops during dry spells. Mixing incompatible chemicals. This is when you combine different fertilizers, pesticides, or herbicides in a single sprayer. Farmers have been doing this, called tank mixing, since the 1950s to save time and reduce trips across the field. But not all chemicals get along. If you just dump them together without checking, they can react. For example, if you mix a calcium-based liquid fertilizer with a sulfate, a harsh chemical reaction happens right inside the tank. The two liquids bind together and form calcium sulfate. The mixture quickly turns into a thick, heavy sludge that looks like cottage cheese. This sludge clogs the sprayer nozzles and ruins the equipment. If you actually manage to spray it, these new, highly toxic compounds can severely burn plant leaves and soak deep into the dirt. This permanently damages soil health by wiping out the beneficial microbes that crops need to survive.